In your initial rates lab, you're going to apply what you have learned about chemical kinetics to determine the initial rate and rate order of a reaction involving iodide and iron. So you're going to take potassium iodide and iron 3 nitrate, and you're going to determine the rate law for this reaction. So let's talk about, once you obtain that data, and your lab handout walks you through how to set up your colorimeter and how to set up the light quest, and then how to prepare your solutions. So let's talk about what you are going to do with that data. So if you look at each of these trials here, what you will notice is for each one, there is the same amount of solution. In trial 1, if we take the 5 milliliters of the 5 milliliters of iodine and the 5 milliliters of iron and no water, 5 plus 5 is 10 milliliters. And the second one, 2.5 milliliters of iodine plus 5 milliliters plus 2.5 milliliters of water, again gives us 10 milliliters. And if you go through these, you will continue to see, and you can add these up yourself just to verify, 3.75 times 2 plus the 2.5 again gives us 10 milliliters. So we're always going to be diluting to 10 milliliters. So if you look at the second page of your lab handout, one of the first things you need to do is calculate the concentration of iodine and iron. So let's do that. We're going to look at 1,2, for example, since 1,2 has different volumes of iodine and iron. So let's take the iodine from 1,2. So we start with an initial concentration of 0.020 molar for both the iodine and the iron. So in 1,2, remember your formula for dilution. M1V1 equals M2V2. We take 0.020 molar times 2.5 milliliters, and that is equal to M2 times 10 milliliters. So if we divide that out, if we take our 0.020 times 2.5 and divide that by 10 milliliters, rearranging algebraically, then we come up with M2 is equal to 0.005 molar. So that's our concentration for the iodine. Now if we look at iron here in 1,2, we take 5 milliliters of iron and we dilute that to 10 milliliters. So if we're looking at 1,2, we have M1 V1 equals M2V2. So we're going to plug in that we have 0.020 molar times 5 molar is equal to M2, this is supposed to be milliliters. So 0.020 molar times 5 milliliters equals M2 times 10 milliliters. So again, if we rearrange this algebraically and take 0.020 times 5, divide that by 10, we find that M2 for the iron equals 0.01 molar. So you're going to do the rest of that for 1,1 and runs 3 through 4 to calculate what the concentration of your iodine and your iron is for each trial. So then once you do that, in step 2 of your data analysis, you have to calculate M and N and the rate law. So you're given the rate law in the introduction. The rate law is K times iodine raised to the M times iron, and you're going to determine what M and N are. So remember to calculate M, what you're going to do is you're going to find two trials where the concentration of Fe3 plus stays constant. And then you're going to determine, as we change the concentration of I negative, how does the rate change? Oops. Oh, come on. Okay, well, how does the rate change as... Let me make sure we're on pen. Okay, there we go. How does the rate change? And then you're going to do the same thing for iron. You're going to see as iodine is held constant and we change the concentration of iron, how does our rate change? So that's going to give us M and N. So in step 3, you're going to write out your rate law. Then question 4 asks you to calculate a value for K. So if you calculate a value for K, your rate you know is equal to K times I negative to the M times iron 3 positive raised to the N. So once you know what M and N are, and you can plug those values in, then you can plug in your rate from each trial, your concentrations of iron, your value of M, your concentration of iron, and your value of N, and rearrange this algebraically. So K is equal to the rate times I negative to the M and that's going to give you your value for K for each trial, and then you're going to go through and calculate the average K. So you're going to add up your average K's and divide by 5. So make sure that you have read through your lab handout and completed your purpose and procedure for this lab and submitted that on Canvas before you come to lab, and I will see you in lab.